Alright, so this is Geometry Chapter 3, Section 1, Lines and Angles. This is a very definition-heavy section. And the first one they talk about is parallel lines. So you guys already been familiar with parallel lines? Parallel has a particular symbol associated with it, and the symbol is these two little lines. Either they're slanted or they're straight up and down. So these means parallel. And according to this book, which I agree with, parallel lines are lines that never intersect and they're coplanar, meaning they're inside the same plane. So if I have this line here, line L, this line here, line M, they are parallel because they're in the same plane, number one. And they never intersect. And so that's parallel. So they say parallel lines. So we have, here's AE as a set of parallel lines. And here is BF. They would be considered parallel. There's so many parallel lines here. AD, BC, CG, BF, AE, DH, HG, EF. They're all within the same plane. And they never intersect, parallel lines. The next one we have are skew lines. And this one's a little different in terms of seeing them. Skew lines are lines that never intersect they never intersect, they're not parallel, and they're not coplanar, meaning they're not in the same plane. They never intersect, they're not parallel, they're not coplanar. So there's a few here. It's one says AB and CG. Here's AB and CG. AB and CG. Now take a nooks. AB is going in this direction, right? CG is going in the upward direction. They're not parallel, but notice that they're not in the same plane. AB is in the front plane, and CG is in the back plane, or the right plane, and they're never going to intersect. This guy is in the front, this guy is in the back, this guy is going up, this guy is going left to right. These are skew. There's other skew lines as well. We can say ODC and AE. This guy is in the front, this guy is in the back. They're never going to intersect. This guy is going left to right, this guy is going up and down. They are skew lines. We can say FG and DH can also be considered skew. DH is going up and down. FG is going left and right. FG is to the right. This guy is to the back. They're never going to intersect. These guys are skew. Not only are lines parallel, but you can also have parallel planes. So parallel planes are just planes that don't intersect. Planes that don't intersect. In this case, we can have plane A, B, and C. We have plane H, G, F. This guy is on top, this guy is on the bottom. They're never going to intersect. They're parallel planes. We have plane CBG. We have plane AHE, left and right. They're going in the same direction and they will never intersect. They are parallel planes. Oh, shoot. Okay. Parallel planes. Okay, now these are just asking you what's parallel and what's intersecting and skew and stuff. Alright, so here we have something called a transversal. If we have two or more lines, we have line L, we have line M, right? We have this thing called a transversal. A transversal is a line that cuts across both of the lines. This is my transversal, line T. We're going to call this the transversal. It's the line that cuts across two or more other lines. It's a line that intersects two or more other lines. It says it's coplanar, they have to be within the same plane. You know, angle 1, 2, 3, 4, 5, 6, 7, 8. And when you have a transversal cutting across these two lines, we have a whole bunch of angles that are created from this. Namely, in this case, 8 angles. Anything that's in between the two lines, it's called the interior. Anything between the two lines is called the interior. Anything on the outside of the two lines is called the exterior. Anything between the two lines called the interior. Anything on the outside of the two lines is called the exterior. So we have two lines cut by a transversal that intersects both the two lines. Line L, M, and T are all in the same plane. They create a bunch of angles associated with it. If the angles inside of the line, so this is going to be angle 4, 3, 5, and 6. Angle 4, 3, 5, and 6. They're in the interior. These are interior angles because it's in the region that's in between the two lines. While angle 1, 2, 8, and 7 would be called exterior angles because it's in the region on the outside of the two lines. Angles 4, 3, 5, and 6 are interior. Angles 1, 2, 8, and 7 would be considered exterior angles. Whoa. Okay. few more definitions and then we're done. Alright. Draw this again. Line L, line M, my transversal. Yeah. So we have the first set of angles, and they're called alternate interiors. So we'll say 4 and 5. No, 4 and 6. 3 and 5. These guys are called alternating interior angles. So I call it AIA. Alternating interior angles. You can look at it over here. And the definition says that alternating interior angles are non-adjacent interior angles that lie on the opposite side of the transversal. Okay, so this is our transversal, right? This is our transversal. This is our transversal. 4 and 6 are considered alternating interior angles. They're non-adjacent, meaning they're not on the same side. They don't share a common side or a common ray. And they're on opposite sides of the transversal. This guy is over here to the left. This guy is over here to the right. 3 and 5 are also alternating interior angles. They're in the interior, in between the two lines, and they're on opposite sides of the transversal. And they're non-adjacent, meaning they don't share a common endpoint. They don't share a common endpoint. This would be the common endpoint of 3 and 4. They don't share that. They're not common. They don't share a common side. They're not adjacent, so they're on opposite side of the transversal. Okay. One way that I think about them, I'll rewrite this a little bit, is if I was to go 1, 2, actually I'll say that to the end. Alright, then we have same side interior angles. Four and 5, 3 and 6. They're interior angles that lie on the same side of the transversal. Interior angles that lie on the same side. So we have 4 and 5. Here's my transversal. 4 and 5 are on the same side, so same side interior. 3 and 6 are on the same side, so same side interior. You can call it same side interior. I've also seen it called consecutive interior. This is actually the way. This is the way that I actually know it as consecutive interior. But for this guy, we'll call it same side interior, SSI. Then we have something called corresponding angles. Actually, before we get to corresponding, let's do executive exterior and alternating exterior. One and 7, 2 and 8. These are alternating exterior angles. They're not adjacent. They don't share a common endpoint. And they lie on opposite sides of the transversal, and they're on the outside. They're on the outside. They're the exterior angles of the two lines. So 2 is up here. 8 is down here. They're on opposite sides. 1 is up here. 7 is up here. They're on opposite sides of the transversal. And then they'll share a common endpoint. So if you think about it as here, you would flip it and then slide it down. 2, you would flip it and then slide it down. And they're in opposite areas. Alternating exterior angles. Okay, then we get corresponding. I don't think I have enough colors. I don't know. Then we get alternate exterior. So 1, 5, 2, and 6. 4 and 8. 3 and 7. Maybe I do. So here's the thing about alternate exterior angles. Think of it as this. I always put it in 4 categories. So I have TL. TL means top left. I have TR. TR means top right. And it's always along the intersection point. So top left, top right of the intersection. Then I got bottom right or bottom left. And bottom right. Okay? So bottom left, bottom right, bottom left, bottom right. So if I look at these guys, and we see that angle 4 and 8 both occupy the same region of their intersection point. So it's in the bottom left. Angle 8 is also in the bottom left. So they're corresponding. They occupy the same place at the same time. So the definition the book gives is corresponding angles are angles that are the same side of the transversal and the corresponding positions. I hate when you use corresponding to describe corresponding. So the symbol that I do is I do corresponding angles like that. 4 and 8 are both in the same region of their intersection. They're both in the bottom left, so they're corresponding. 3 and 7, they're both in the bottom right, so they're corresponding. 2 and 6, they're both in the top right, so they're corresponding. 1 and 5, they're both in the top left, so they're corresponding. They're in the same region. They occupy the same area of their respective intersection points. Hence, they are corresponding angles. So here, for the thing, they want 3 pairs of corresponding angles. 2 and 4 are corresponding. You can say this guy is in the top right, top right. 5 and 7, they're corresponding, bottom right, 8 and 6, they're corresponding, bottom left, 1 and 3, they're corresponding, top left of their respective angles. All right. Here, they want to know what angles 2 and 4 are. So here's 2, here's 4. Here's my transversal. Here's my transversal. These guys are my other 2 lines that's cutting the transversal cut across. 2 and 4 are on the interior of the 2, so we know that they're interior angles. So they could either be same side or alternate interior. They're not on the same side, so they can't be same side interior. So these guys are alternating interior. They're on opposite sides of the transversal and the interior, and they're non-adjacent. So they are alternating interior angles. By the way, 1 and 3, they would be considered corresponding. 2 and 3 would be considered same side. And there is no exterior angles except for 1, so there is no alternating exterior angles. Okay, so that's that section. Hope you have a great rest of your day.